Go ahead.
All right. Hello, everyone. My name is, as Judy introduced, my name is Sunil. I live in Northern Virginia. I've been working on a startup for the last 2.5 years called Fast Code. And so I wanted to take this time, and thank you so much for your time. Wanted to spend maybe half an hour talking about low code platforms and professional developers like yourself, because there seems to be a mismatch in the current low-code platform offerings in the industry versus Java Spring Boot developers. And I'll discuss that a little bit. And this topic is relevant because pretty much every enterprise nowadays is adopting low-code platforms. And if you Google online, you'll see a lot of discussions about what does that mean for professional web application developers. I mean, does that mean they'll have to transition to learning low-code platforms, or what exactly is going to happen in the industry? So I think it's kind of a relevant topic. So I'll get started. So let's start with the problem, why these low-code platforms exist, and what is the problem they're trying to solve. Essentially, they're trying to solve the problem of what you can call enterprise IT application backlogs. So the number of applications being created by enterprises is actually accelerating because every enterprise nowadays, is trying to become a digital enterprise, and they have all these digital transformation efforts. But, they say the number of developers is not increasing as proportionately. So there is typically this manifests itself as a problem in enterprise IT application backlogs. So typically what happens is somebody from a different function, sales, marketing, etc., goes to IT and says, hey, I want this particular application to be developed. And IT says, okay, we'll put it in our pipeline and we'll see you after a year. That's when we can start because we have a whole bunch of applications we need to develop first. And that's creating more tensions between IT and business. And and so there are a couple of ways to solve this problem. So what the industry has done is it has come up with two distinct approaches. One is, one way to solve this problem is to expand the number of developers available. Obviously, you can't manufacture developers. So what they have done is they created platforms that enable people who have historically never developed web applications, like people with, maybe Excel sort of skills, Microsoft Excel sort of skills, or people with basic technical knowledge like HTML, CSS, maybe a little bit of JavaScript, maybe a little bit of SQL. So these people have never developed web apps in your traditional sense. They are not your professional web application developers. So they provided platforms to enable these developers to develop applications, thereby increasing the developer pool to solve this application backlog problem. That is one approach. The other approach is, take your existing professional developers and accelerate their development velocity in the sense that, for example, if you can double the speed at which they can develop web applications without disrupting their, traditional way of development, then that could be another approach to solving this backlog. So most of the companies in the industry have taken the first approach, which is, through what I call as no code and low code platforms. So no, I mean, pretty much all the tech leaders are in this space, including and obviously some very well funded startups. There are some startups here which got funded $500 million. So their no code platforms are for business experts, like people, as I said, who are like, domain experts and also have good technical skills from the perspective of Microsoft Excel, or Microsoft Access database, etc. So the no code platforms are catered towards these type of users. And, as the name says, no code means like typically you don't have to develop any code. It's mostly a drag and drop type of environment. So some of the applications, for example, if you want to put a form on the web, so that's a typical application. of these no-code platforms. And low-code platforms are for slightly more complex applications. Here, the users are people with basic technical skills like HTMLs, CSS, etc. And again, you see a whole bunch of vendors in the space. And you can develop slightly more complex applications with the low-code platforms. Although if you talk to the vendors, they'll say they can develop any application.
Sunil, did you have slides?
Oh, I mean, not.
No, you weren't sharing your screen. I thought you were just waiting. Yeah.
Oh, Lord. Okay, sorry. Oh, I thought I was sharing. I guess I stopped it in the middle. Sorry. Okay. Can you see the screen now?
Yes.
All right. So I was just talking through the slides. Okay, so I'll just summarize it. So no code is for simple applications, and the users of no code platforms are business experts, people with Excel skills, Microsoft Access skills, etc. And low code platforms are for developers, not your traditional app developers, but people with basic technical skills like HTML, CSS, and you can develop more complex apps with the low code platforms. And as you can see, pretty much every industry leader is in the space. Okay, so so today we'll focus on low code platforms, specifically because I think those are more applicable to professional developers like us. And so the great thing about low code platforms is it can double the speed at which you develop applications. So previously, if it used to take 6 months to develop an app, now you can do it in 3 months or less. Okay, but there are disadvantages with this low code platforms, especially for professional developers like ourselves. From an enterprise perspective, the most important, the biggest problem is vendor lock-in. So typically, if you, unlike your Spring Boot or Java app, which you develop and then it can run on any Tomcat container or like any servlet container, right? The apps you develop on these low-code platforms can only run on the platforms themselves. You cannot like take it out and run it outside on independently. So what happens is today enterprise buys one of these platforms and like in say 3-4 years, they develop like say 50 applications. Then you're stuck with the vendor because you can't get rid of the vendor for whatever reasons, or if the vendor goes out of business, you're out of luck because you can't run those apps anywhere else. So vendor lock-in is a big issue. Next, talent availability, because these platforms are very proprietary in nature. So if you take two different companies, their platforms are totally different from a low-code platform perspective. And so finding people who have experience in a specific platform that we have purchased is very difficult. Unlike hiring a Java or a Spring Boot developer, right? Because Java and Spring Boot are adopted so widely across industry that you can easily find people who have that experience. But these low-code platforms are very proprietary. They have probably a few hundred customers, so it's very hard to find experienced people. And the third thing is, you can't really leverage your .NET, Java, Node.js developers. So if you're enterprise in in your IT department, you already have these professional developers. You can't really leverage them because these platforms, low-code platforms, are not suitable, as we'll discuss. They're only suitable for people with the basic technical skills, not your professional developers. Now, from a professional developer's perspective, these low-code platforms are a lot of people don't like them, and the number one reason is the couple of important reasons are, one is you have no control over the source code. So these low-code platforms, typically you drag and drop, even for doing your basic logic, business logic, like if you have a if then else statement, you drag a if block, then you drag a then block, and then you drag a else block, and you connect. That's how you develop your business logic. And you don't get to make any changes to the source code because we have absolutely no control over it. And the problem with not having control over the source code is if the business logic is very complex, then can you imagine like, dragging and dropping hundreds of different statements instead of just coding it. So developing complex business logic becomes very, very difficult. And, and the other big problem is debugging. You can't really set breakpoints and, try to figure out what the issue is. So debugging is another big issue. Second big issue is career mobility, right? So if you work on one of these platforms for a couple of years, say you take, OutSystems as a leader in low-code platforms. If you work on OutSystems for a couple of years, then the jobs you'll find after that are only, most likely, in other enterprises which have adopted OutSystems. Okay, and there are much more fewer enterprises which have adopted OutSystems compared with those who have adopted, Java or .NET. Right, so your career mobility decreases when you work on these low-code platforms. And finally, there's a learning curve associated with it, which is not a big deal. We all love to learn, but it's a different paradigm of learning because it's not learning a different programming language. It's like learning essentially how to drag and drop things and build an application. Okay, so these are the advantages and disadvantages of these low-code platforms. I mean, the advantage, as I said, is you can cut the development time and cost in half, but they cause disadvantages both for enterprises and professional developers. So here is a survey which was done by one of the leaders in low-code platforms. They asked enterprises about what are the barriers to adoption of low-code platforms. Obviously, the first one was obviously people didn't know about them. But the second most important thing was the vendor lock-in I just talked about. And the third one was like, hey, we don't believe we can develop complex applications because of the business logic involved and all that. And then there were concerns about scalability, security, and all that. Okay. So enterprises kind of still are like a little bit tepid, in adopting these platforms, but it is still, it's kind of accelerating. The adoption is accelerating, and Gartner actually predicts, I think, by 2023 or so, 50% of all enterprise apps will be developed using low-code platforms. So the adoption is really accelerating. Now, if you ask developers what they think about it, professional developers, generally, as you can see in the circle here, generally they feel negative about the adoption. They have asked developers and also architects and managers, and most of them feel negative about it. So the challenge here is then enterprises want to reduce the time and cost of development because they have no choice. They're going on digital transformation efforts. And but at the same time, professional developers don't like using these platforms. How do you solve this dilemma? Right. One way enterprises are doing it is they're hiring other people who are not professional developers, like people straight out of college who have basic technical skills, and they're making them develop apps using these low-code platforms, and then they're using professional developers for other purposes. So that's one way to solve it. But we felt like when I started this like 2.5 years ago, I mean, this was not like a big thing. It was just at a very early stage. And I kind of felt that a platform is needed for professional developers. And I was a Java developer, Spring developer. So I started with building a low-code platform for professional developers. Okay. What we need is, as I said, a low-code platform for professional developers. It should also be able to double the development speed. Otherwise, enterprises are not going to adopt it. And it should also eliminate all the disadvantages we talked about the low-code platforms, both for enterprises and for professional devs. And so how would such a platform work, and what would it look like? Okay, I mean, I kind of know what it is, but because we have actually built one. But typically, other companies which are building such platforms are following a similar approach. Okay, so I'll be generic here. So, the way it works generally is in 3 steps. The first step is, you have your data model, either your tables, relationships, or your domain model. For example, all your JPA entities and the relationships. And then you have some kind of application generator, which reads either the data model or the domain model and generates the front end and back end of the application. And when I say front end and back end, the back end will be say a REST API, and the API, all you can do with the REST API is to CRUD the methods. You create, update, delete, find type of methods on each of the database tables or entities. And the front end is going to just provide screens to perform those operations. So if there is a create customer, you need a screen to show all the fields, a form to display all the fields. And so that is what is going to be generated from the database schema or domain model. And once you generate it, probably that will take you to, I don't know, like it depends on the application, but like it may take you to 30%, 40%. But the other thing you can do when you're generating the application is add plugins. So when I say plugins, essentially, it's a common functionality that you use in most enterprise applications, like things like authentication, authorization, reports, and dashboards. So if you have plugins that you can add during the application generation, so instead of taking you to 30-40%, it may take you to 60% of the completed application. And finally, the last step is, you need to finish. Once you generated the application, I think typically what will be remaining is not your current screens, but your custom screens that you need to, because every application will have some custom screens which are not CRUD screens. So building those screens and building the supporting APIs on the back end is one piece of work which will typically be remaining. The other piece of work is, what is that? So other functionality like non-functional requirements that you need to fulfill. So let's look at each of the steps. So, I mean, you all know what this is. This is just a small example. I mean, I've used a Spring Pet Clinic here as an example. And so this is your schema. This is how it looks like. And then the second step is, so first you need to build this. Maybe the platform will provide you like a ER model designer or whatever is necessary for you to build this model. And in the second step, you generate the application to what you call as an application generator. The application generator, for example, in the Spring world, OpenJPA, there is a OpenJPA has something called reverse mapping tool. I think even JBoss used to have it, but like they read a database and generate the entities. Okay, so this takes it further, the application generator. In addition to generating the entities, it also generates all the layers on the back end, your DAO layer, your services layer, and your controllers. And also the front end, whatever language, whatever framework you want to use, whether it's Angular, React, whatever it is, generates the application. And it has the capability to generate everything in one shot, or in cases where you're developing a big application and you're developing a data model in stages, like initially, for example, you may just develop the payment module. In the second stage, you may develop like inventory module, right? So this should be capable of incrementally generating the application as well. So this is how it looks like. As I said, front end could be in Angular, React, backend could be in whatever you want as well. And the typical architecture, is your traditional n-layered architecture. And it also, in addition to generating just the code for the layers and the front end, it'll also generate all the relevant infrastructure components for your standard things like logging, exception handling, database versioning, unit. Another big thing is unit integration tests. So for example, the other day I was using a product and it was a 15 table schema, and I generated an application, and it's only 15 tables, but the number of unit and integration tests I think we generated on the back end was like 750 unit and integration tests. And on the front end, it was also something similar. And obviously, a lot of developers hate writing unit and integration tests. So at least for the CRUD methods, I think, you're taking care of. So this is what is generated. And as a part of this generation, as I said, you could use add-on modules that you can plug in. These are like things, and I say add-on modules. These modules are like what you call cross-cutting concerns, essentially things which reoccur again and again in every enterprise app. So authentication, authorization, reports, job scheduling, using something like pods, right? And email templates, email APIs, user auditing, etc. You can keep building this, but if you have the application generator can plug in as a plugin system, then you can easily plug in all these modules. So with the CRUD screens and CRUD REST API plus these add-on modules, it will probably still take you to 65–70% of the completed application. But then you need to do two things, right? One is you need to develop your custom screens, and second thing is add business logic, right? So once this is generated, all the source code will be available to you. Okay, so it'll be your traditional Angular Spring Boot project, two separate projects. And finally, the last step is to customize the application. Here, platforms provide different tools. So for example, they typically provide like a visual UI builder. What it can do is you drag and drop, say, if you're using Angular material has a library of 40 different components, or 35 to 40 different UI components. You drag and drop them and onto a flex layout, and you click generate, and it'll generate all the code in Angular. Okay, so these are, this can be used to rapidly develop your custom screens, so versus doing it manually, it can at least cut it down by 50% for each screen, the amount of time you spend. And same thing with theme builder, because your application, which is generated, has a certain theme, but if you want to use it to, if you want to apply your corporate standards, branding standards, a theme builder can be very useful. And lastly, integrations, right? No enterprise application sits in a vacuum. They typically want to interface with other enterprise applications. So for example, when you create a new customer in your application, you may want to immediately push that customer to Salesforce, right? So integrations builder easily allows you to drag and drop and quickly create integrations. So typically integrations builder is built on top of Camel, Apache Camel, so that you're still using the same stack underneath. So that's the third step. So these are tools for customizing the application. So as I mentioned, like, I went through the three steps. One is designing your data model. Second is generating the application, which generates both the CRUD operations plus add-on modules. Third is like customizing the generated application. Okay, so we said a platform which caters to professional developers need to not only offer speed of development, but it has to eliminate all the disadvantages of traditional low-code platforms that exist in the market today. So how is that possible? Okay, let's look at each one of them. For the enterprise, we said vendor lock-in is an issue, because if you develop an app on this platform, it cannot run elsewhere. That's not a problem here, because we are developing essentially a Spring Boot app. which will run anywhere, right? In any servlet container. You don't need any platform. It's not locked in to a platform. Second thing is talent availability is not an issue because you have plenty of Java Spring Boot developers available in the market. Can't leverage your pro dev staff. If you are a Java shop, you already have Java developers. You can totally leverage them instead of hiring somebody else with basic technical skills and making them work on a different existing traditional low-code platforms. So all these three disadvantages go away. Okay, and obviously for the professional developers, is no poor development experience because they have full control over the source code. So once you generate an application, the entire application source code, you can just open it up in IDE of your choice, IntelliJ, Eclipse, or on the front end, I typically use VS Code. So it's just as if you developed it on your own. So development experience, you can develop complex business logic just like you do today. You can set breakpoints, easily do debugging, etc. Now, we don't limit your career mobility because we are not forcing you to work in any stack that you're not familiar with. And so you're continuing to work in the stack you always worked on, like Spring Boot or React and Angular, etc. And really, there's no learning curve. I mean, very little learning curve, if any, to understand how to use a visual builders. But other than that, you're dealing with just your traditional code, Java, Spring Boot, and whatever front-end stack you choose. So all these disadvantages we talked about associated with low-code platforms in the market today are eliminated. But at the same time, the advantage of speed is preserved because we are generating a lot of code, we are plugging in modules, we are using visual development tools. It can also cut down the time by 50% or more. All right. So, so the developer workflow looks like this. Something like be an app portal where all the apps are created, and I can show you a quick demo if you like to see later. And once you create an app, I mean, you're essentially, what you're doing here is you're generating an application using the application generator. You're pointing that application generator to your data model, for example, in the database. And it reads the data model, generates your front end and back end. And it checks in all that generated application into your enterprise Git repository. And from there, you can just check out each developer working on that particular application can check out and just use the visual development tools, which will be added as extensions to your IDE. Okay, so that's how this works. I mean, this is not too different from what you do today. So essentially, whatever I explained is what we are also doing, and some of the other companies in the space are doing as well. Okay, so that's pretty much what I had in mind. If you have any questions, happy to answer.
You want to show us the first couple slides that we missed?
Yeah. There isn't much actually in the first couple of slides. So this was the first slide, which is the number of applications being developed is increasing more rapidly than the number of available talent pool, resulting in application backlogs. And this was two ways of solving this backlog. One is to make people who have never developed apps, provide them platforms to develop apps. Okay, this is where no code and low code platforms play a role. And then the other way is the approach we are taking, which is, build a platform for your professional developers to double their speed. So the second approach it preserves the advantage of the first approach, which is the speed, but at the same time eliminates all the disadvantages. And I think you've seen this.
Okay, so I'll ask a question. if you have this generate your code and then it goes into Git and then your developers have it to do stuff with it, once it's in their hands, it can't go back into the app, right? Do you know what I'm saying?
Yeah, I mean, like, so once it's in your hand, say you check it out and you open it in your IDE, right? Then we provide visual development tools like UI Builder, Theme Builder, like these three tools I mentioned, which is these three tools as extensions. So, for example, if you take something like VS Code, like if you're doing front end, because these are front end tools mostly, right? So once I'll show you actually an example of a generated application. Yeah, so this is a small schema for timesheet, for filling timesheets, And so this is a generated application. So this is the front end in Angular, and this is the back end in your Spring Boot, Hibernate JPA, right? And the structure, everything looks exactly like you develop, Java, source, etc. And here on the side, you see VS Code allows you to add extensions. So does IntelliJ and Eclipse. So here you'll see the UI builder icon, a theme builder icon, an integrations builder icon. And once you click on it, this whole central screen will become the UI builder, and we can drag and drop components. And you click on some button, generate source code. Source code will be generated, will be added to your directory here. Okay, whatever directory you specify. So the experience is, to answer your question, yeah, you have full control over the source code. If you don't want to, I mean, only other thing we can do in addition to providing this is host it for you. And that's an optional thing. If you don't want to host, if you don't want to have a hosted experience, you can just do it just like this, on your local machine. You can download the source code and open it up in IDE, use the visual development tools here, and develop your application. And that also, I'll quickly show you this is how our app generation portal looks like. Okay, so you can just come here, just log in. These are all the applications which were previously generated. So if you want to generate an application, all you do is something like create an application here. And we have a sample application that you can use. So you go here, there's a timesheet schema. And just if you want to check it into a Git repository, you specify, for example, GitHub, what your account name is and all that. You can provide that information. So, and then after that, you just go through the steps here. There are a total of 9 steps, which allows for different customization options. So for example, like on the front end, if there's a customer table, what should be the default sort column? Things along those lines, different authentication methods. So you go through this 10 steps, and at the end, you'll end up with something like this. And here, you can just go and download this application. And it will be downloaded as zip file. And once you open it up, it'll look exactly like what I just showed you, like this. So it'll have a front end and a back end. So timesheet is the back end and timesheet client is the front end in Angular. And then, you'll also have the visual development tools here, which I don't have right now, but you can click on them and further customize the application. So it's not very different from what you do today. Only thing is we are accelerating your development by taking off all the grunt work involved in developing all these CRUD screens and also all the standard things you do in every application like authentication, authorization, reports and dashboards, and all those things are essentially something we can generate out of the box and allow you to customize.
Pretty cool. Anybody have some questions? We have a very quiet audience today.
Hi, team. Hi, Sunil. This is Ronak here.
Hi.
Hi. So I see that you're also we are using the Lico base as well. Is it something we are using only for the only database or the DB deployment, or like sync up, or like how are we using?
Oh, for using Liquibase. So Liquibase we are using for right now. There is some initial data to populate some initial data. So as soon as you download it and run it, some Liquibase scripts run, which take some initial tables we wanted. For example, to create a default admin user, right? So to populate initial data is one place where we use it. The other place is, once you download it, nothing prevents. There are two ways to make changes to the existing application, right? One way is you change your data model. Say you want to add an additional field to your to a table, to say a customer table. You want to add like a customer last name. Then you can potentially, then in that case, if you change your data model, you can come here and you can regenerate the application, and it will preserve all the changes you have previously made also, because we have a concept of extension classes and all that. Okay, but if you, from a Liquibase perspective, if you make changes directly to your entities, right? So if you have a customer entity and you extend that customer entity with the last name, then the thing is now your entity model has changed, but now we need to update the database accordingly, right? That's where that's the second place where we use Liquibase. Liquibase automatically runs and creates those additional proper table fields or additional tables or whatever database schema changes are involved.
Okay, thank you, Sunil. Yeah, because just in my current company, we do use Liquibase as well in our day-to-day deployments. But we are through our Jenkins.
Oh yeah.
And then we just running like all of our the DB database changes we do it through Liquibase with the changelog XML and all that. So.
Right. So we actually I think we have it somewhere here. Let's see. Yeah, Liquibase. Yeah, these are all the Liquibase XML things you're talking about.
Yeah, I think that there will be the changelog XML. I think there is a master.
Yeah, there is a master. Yeah, this is the master changelog XML.
Right. So that's something where whatever scripts directly
Right.
give the location of the SQL scripts from there, and it will run.
Correct. These are all the scripts we said we included, and
okay. Yeah. Thanks.
Thank you. So I guess no other questions. But one of the things we are doing is we are conducting a free proof of concept with anybody who's interested, any companies. So if you're interested, just get in touch with me. Essentially, this is my email address at the bottom. So we just want to let you experience the platform to see whether that's something which will be useful for you. Okay, I guess I'm done, Judy.
Thank you. Thank you very much. I am going to stop recording. Okay.